You expect the best, so demand the best. Thunder Tiger has the right machine for you. Whether you're just getting started, ready for aggressive 3D performance, or ready to experience the thrill of ultimate 3D performance. Take your flying skill to the next level with Thunder Tiger.
Jacks it up, takes the ball. I mean, that's just a compliment to how outstanding he is behind the plate because of the fact that he is a lifetime 290-something hitter.
Lifetime 294 coming into this year. Nobody out, 2 on, and a 1-1 pitch.
AJ almost did it again. That's how he hurt his dang back toe last time. I mean, excuse me, his front toe. He moved his back foot and got hit in the front foot. He almost miscalculated once again.
Big pitch right here.
Hello? Okay, I'll be there. Yeah.
Take a look at what
See ya.
Pierzynski does on this pitch inside.
Hey, what? Is everything ready? Of course. What about my hands? Yeah. Where are they? In the box over there in the corner. Oh. Here, move this. Oh, God. Let's see here. Here we go. Glasses, hat. There's my hands. Hi, I'm Szabo Jr. and welcome to Ultimate Heli 3D. I'm sure you guys are very eager to learn all the 3D maneuvers I've been doing lately, but first we need to go ahead and overview our helicopter selection and as well as our proper radio setup. So I need you guys to go ahead, sit back, relax, and plan on spending some time with us. First thing we need to talk about is helicopter selection. Today I've chosen the Raptor 90 SC due to its simplicity of design and cost. The reason for a 90 size helicopter is the higher power to weight ratio. The reason for the higher power to weight ratio is for the new generation of 3D flying. Now if you're not ready for a 90 size helicopter, there's many 50 size helicopters that are out there with the same close to power to weight ratio as the 90s. Now I know there's a lot of 3D capable helicopters out on the market, but due to the simplicity of design and cost of the 90 SE makes it the right machine for me. The second thing you need to think about is engine selection. I'm using the OS91 C-Spec PS because of its torque and good top-end power as well as its smooth running characteristics. Some of its features include running muffler pressure, an external pump, and a return carburetor. The biggest reason I've chosen an engine with so many features is due to its reliability when pushing such hard 3D maneuvers. So when choosing an engine, the two most important factors are reliability and power. The next subject we're going to talk about is blades. Here I'm using the V-Blades 690s. The reason for it is because they have the stiffest torsionally and longitudinally blade out on the market right now. And that gives me a quicker collective and a crisper cyclic response. I wish I can tell you guys that the 690s are going to work perfect for your machine, but the bottom line is you're just going to have to experiment with different sizes. Okay, the next thing we're going to talk about after talking about our main rotor blades is our selection on our paddles and tail blades. As we can see here on our paddles, here we have these carbon fiber V paddles. They're much lighter than the stock Raptor paddles. They weigh around 18 grams. I mean, we'll kind of do a sound test. It's kind of a jimmy rig type thing, but here we go. You can hear that sound compared to a standard size Raptor 90 paddle here. We'll go ahead and hear this one. A lot more of the thud. I don't know the true weight. I think they're around like 30 some grams, but the lighter the paddle, the faster our response is going to be on the helicopter, which is what we're looking for in our extreme 3D flying. Also, we have our tail blades. The biggest thing we're looking in our tail blades here, I'm using these V-Blades 105 millimeter tail blades. The reason for this is the actual stiffness of the tail blade. You guys can see that it's really stiff in all directions. When we compare that to a standard tail blade here that's made of plastic, I mean it's just very flimsy, which makes our gyro work like 5 times as hard. And it also just, with a carbon tail blade, we're just much stiffer. There's different lengths that you can try. That's just something you'll have to kind of experiment on your own. Okay, our next subject I want to talk about is governors in general, but more, into what we're using here is the model avionics rev limiter, or Rev Max as it's called, but it's what it really comes down to being is more like a limiter more than a governor. But what we're doing is we're using a pickup, an optical sensor pickup on here. The optical sensor is actually an option part from what the governor or the Rev Max comes with. It comes with a magnetic sensor which works just as well as the optical. I wouldn't make it any preference on what one's better or anything. They're just whatever you want to use. It's just a personal preference on that. But what we're looking at is basically the way it functions is kind of like your car. It won't allow you to over rev, as we can call it. We set the limiter at a head speed of like 1850, and what that will do is we can set up a throttle curve, which will give us more performance than a governor normally does. And all it will do is keep it from over revving that 1850 that we set in. You can find out more information about the rev limiter because it's kind of hard to explain in a short amount of time, but on the Model Avionics website you can go ahead and check out a little more specs about it, as well as a comparison between the rev limiter and the Rev Max and the Throttle Jockey Pro. Next, we need to talk about radio equipment. Today, I'm in my Raptor 90 SC. I'm using the Airtronic stylus, along with all Airtronic servos, which are the 94 758s, which are spec'd out at 0.07 with 100 ounces of torque. Those numbers might not mean anything to you at first, but here, let me go ahead and show you what we're kind of a visual demonstration on really kind of how fast that really is. Here we go. As you can see, that's pretty impressive for speed-wise. The only problem with using these servos, there is one small drawback, and it's battery life. In this model, we're using the Duralite 4000s as well with the 5.1 regulator from Duralite. Without that setup, you'll have to use about a 3000 milliamp NightCat, and that'll probably only last you about one flight. That's just, you know, something that is a drawback about using high-speed servos. Because of the high-speed servos that we're using, what this does is it gives us a very quick, crisp cyclic. When you mix that in with light paddles and very stiff blades, it's just, I mean, it's like having power steering on your car. I mean, it's beyond that. Some people talk about, you know, using CCPM. This is just your standard mixing, which shows we have one servo for each movement on the helicopter. Where CCPM, we're using all three of those to move this one swash plate. So it would take two servos for this, and then three servos for that, and then another three servos on your collective. In order, you know, our pros and cons is with CCPM, you kind of get a interaction with a lot of radios and servos. It has some pros, such as it normally will have a little more powerful collective than a conventional setup such as this. But one of the big cons is, in the model industry, is crashing. Well, with a CCPM machine, when you do crash, you 99% of the time will take out the gear sets and all three servos, just because of such a direct linkage setup right to the servos. So it really does put a big impact on them. Where with a standard conventional system, we can kind of get some flex and possibly, you know, have everything give before our servos take the big beating. Now, a lot of people overcomplicate trying to set up a 601 gyro. So here we go. This will be the pretty much the quick go through, and this is actually how I do all mine. This isn't just cutting corners or anything. This is just the real, I guess you can call, Szabo setup on a 601. Let's go ahead and look at the servo we're using, or the servo arm, I should say. We're running, I believe it's 17 millimeters. Just one of the standard servos the 601 comes with, or the servo arm, I should say. 17 millimeters out, and the governor gain is set at 37%, and we're running in F3C mode. For a lot of you guys that are trying to run it in 3D mode, I really couldn't give you a true definition between the two. I haven't experimented with that myself, but only other thing to set besides the 37% and the F3C is just the endpoints. The ATVs or travel just in the gyro box. Other than that, I'd leave everything else standard. And when we want this at 0 or on a vertical 90-degree mark, we want to go ahead and go back here and set this to a rough estimate of approximately, around 3 to 5 degrees of pitch, biting into the opposite way of the torque. So it's just, all it does is just helps out the gyro work a little more efficient. Other than that, we're done with the gyro, and we can move on to bigger and better things. Okay, the final step before we can go flying is our final little tweaks on the radio, which really doesn't come with much. All we're going to go ahead and do is basically center our servos and go ahead and set up our travels. So we'll go ahead and start with elevator here. What we want to do is get it on a vertical 90 degrees on the elevator here. And what we want is a vertical right here with a vertical back over here on all these level elevator arms, which should give us a level swash plate. And then that transfers up into a level 90-degree paddles. So that's where we want to go ahead and start off with the elevator. Once we've accomplished that, what we'll go ahead and do is set our travels on the elevator. What we're looking for is at our full cyclic movement here on the stick, we want no binding on the radio. So what we're looking for is every little movement basically on the stick actually transfers into something on the swash plate. In both directions we're looking for that. Because if we're overdriving that, you can decrease the life of your servo and also decrease the life of your battery in a flight, or throughout a charge really. And we'll go ahead and do the same thing on our aileron servo. We're looking for the same thing, 90 degrees here, and we're looking for actually a match set over here between these two, and we're looking for basically a 90-degree rate in here. And then we're looking for a perfectly flat swash plate. And in order to get that, if these are off, is just, of course, just small swash plate increment movements on the links. Very small adjustments. And again, that just transfers up to flat paddles when we're on the aileron side. Everything should be 90 degrees on the head. So that goes and finishes up our cyclic setup for our endpoints and our centering. And we're basically ready to go trim out the helicopter in flight. After the cyclic, we want to go ahead and set up our collective and throttle curves. Actually, we first want to go ahead and do the mechanical setup. On a Raptor, what we want to do is go ahead and set the collective arm here at 90 degrees. And by doing that, what we're going to be looking for is, coming up on this link, we're going to adjust this and these to get a 90 degree line up here on the mixing arms. Which then what we want to do is go ahead and adjust our links up on the head for our pitch lengths to get our blades at 0 degrees pitch. This is basically our standard setup for a Raptor. You want to go ahead and go from there for your personal preference on what you want in the center for your normal mode. If you want a quick linear movement, such as what I'm using for 3D, you definitely want that in your idle up curve, is just a nice linear movement all the way throughout the collective. And for a throttle curve, what I'm using, because I'm using the rev limiter, or the rev max, which is a limiter, it only will allow the head speed to only go to what you have it set to, not over. So I'm running a 100% throttle curve in my idle up. So throughout the entire flight, the throttle's trying to go to 100%, but the rev max is backing it off to keep it under 1850. And after that, we've done our gyro, we've done the cyclics, we've done our collective and throttle, and all we gotta do is last touch up our rev max to get the appropriate head speed, which we have to do in flight. We're ready to go.
Airtronics has the RC aircraft systems and accessories with quality that you can depend on. From our entry-level analog VG series to our more advanced computerized systems like the VG6000 and the RD series. You may even want to fly like the pros using the Airtronics Stylus radio, which has launched flyers like Alan Szabo Jr. and Larry Jolly into top competition circles. Stop by your local hobby shop and demand the best. We don't make aircraft, we just make them fly better. Get Airtronics. Visit our website at airtronics.net.
Hey, Alan, see how close you can get without hitting them. I just threw it.